Hello, everyone. Good morning. Thanks for coming to this session. I'm Indranil Chakraborty. I'm a product guy with Google Cloud Platform. And together with my colleagues here, in this session, we're going to cover three things. One is the key challenges for Edge and Google Cloud's offering to address those challenges. Second is how do we, as Google Cloud and Google in general, how are we thinking about offering an integrated AI platform? And finally, we'll have some demos for you. So let's get started. So let's start with a simple dictionary definition of Internet of Things. By the way, the counter is not working here. The Internet of Things, if you look at the dictionary, the definition is interconnection of computing devices embedded in everyday things via the internet. Essentially, it is everyday things connected to the internet, and hence Internet of Things. And in this path of interconnection, there are really three interacting units. There's a network of objects that are that connect wired or wirelessly to internet. And the network of objects could be devices, could be appliances, cars, and so on and so forth. Then there are gateways which acts as bridges between these devices and the internet. And finally, cloud, where you want to store the information which you're receiving from the devices and gateways for processing it and then analyzing it to derive intelligence. As you all might already know that it is estimated that by end of 2020, there will be around 25 billion such installed IoT units. And these IoT units would be installed across the consumer segments as well as the business segments. So that's an enormous number of devices connected to the internet. And we are already generating more data than ever with these Internet of Things devices. And so the data generation is continuing to grow. So when Google, around last year, we announced Cloud IoT Core to really help customers, enterprise customers and developers, to manage this massive number of devices and be able to easily ingest influx of data from these devices. So Cloud IoT Core is a fully managed service which allows you to securely connect and manage your devices on Google Cloud. And since our announcements last year, the market reaction, the reaction from our customers and partners has been really positive. It's been phenomenal. I mean, we have customers in manufacturing, smart parking management, healthcare, oil and gas services, who are connecting their assets on the field to Google Cloud IoT Core so that they can connect all these devices securely and then use the rest of our Google Cloud analytics and AI services for ingesting, storing data, and really deriving intelligence. And as we started working with Cloud IoT Core, our focus has been on four critical areas. One is intelligence. So once you collected all this data from the installed units, what do you do with those data? So we want to make sure that we make it really easy for you guys, for customers and partners, to derive intelligence from the data that you collect. Second is scale. So Cloud IoT Platform and Cloud IoT Core is a serverless service, right? So whether you connect one device or you connect hundreds of thousands or even millions of devices, you just connect your devices and we scale internally. As a customer or as a developer, you don't have to worry about adding new infrastructure or adding a new VM instance as you add more devices. So we really have focused on scale. Third is security. We wanted to make sure that each IoT devices there can be individually authenticated, and it makes a secure connection to Google Cloud. And finally, we focused on building up a robust partner ecosystem. So we've been working really hard on these four critical areas. And we identified early on that there is an emergent need for running local services close to the devices itself, to the edge devices itself. And in fact, all these four critical areas are relevant for edge devices as well. And most important of those four was intelligence at the edge. So let's take some example use cases. If you have a camera pointed at your parking lot, where you're using the camera to count real time the number of cars that are parked in the parking lot, it doesn't really make it's not really cost effective, and it doesn't really make any sense to send every frame of the video from the camera to cloud to analyze and count the number of cars that are there in the parking lot. What if you could just do it in the camera itself? And if you have a factory with robots, there could be regulatory reasons. There could be reasons for which you want to protect your IP, and you don't want to send all the data to Google Cloud. You might want to filter some of the data on the edge itself. If you're doing object detection using a camera or some other device, there are, for privacy reasons, you may not want to send all the sensitive data to cloud, but you would want to run some of those analysis and intelligence on the device itself. So based on these, for all these following reasons before, I'm very excited that we announced two new products for edge computing and edge intelligence. One is Cloud IoT Edge. Cloud IoT Edge is a software stack which extends the AI and data processing capabilities of Google Cloud to the edge. And second is Edge TPU, which is a Google-designed, high-performing hardware chip to run machine learning inference on the edge device itself. So let's get a little bit more into the details of these two products. So with Cloud IoT Edge, as I mentioned, it's a software runtime that you can run in your IoT gateway devices. You can run it on a camera. You can run it on any connected device that has some compute capabilities, essentially a device that has a CPU. And Cloud IoT Edge software runtime allows you to run machine learning inference on the edge device itself. It has built-in support for Edge TPU so that you can have lightning-fast machine learning inference on your edge device itself. With Cloud IoT Edge, you can also locally store some of your data. You can process it. You can do translation. You can do some aggregation and filtration before you send the data back to cloud. Android Things is one of our Google's managed operating system for IoT devices, which has got a secure boot. So it's designed from ground up for security and software update. And Cloud IoT Edge runs on Android Things, and we're planning to soon have support for Linux versions as well. And it securely connects your edge devices to Google Cloud. At the same time, we've also added enhanced security through hardware root of trust. And Cloud IoT Edge seamlessly works with Google Cloud IoT Core and rest of Google Cloud IoT platform for hassle-free provisioning. So it's a complete software stack to run machine learning inference on the edge device itself. And there are two key components that enables Cloud IoT Edge for real-time AI on the edge device itself. There's a TensorFlow Lite-based runtime that allows you to run those machine learning inference on the edge, reducing latency and then increasing the versatility of your edge device. And because we use TensorFlow Lite runtime, which is an open source, you can use Cloud IoT Edge with Edge TPU for lightning fast and high-performing performance. But if you have a device which doesn't have an Edge TPU, or your use case doesn't require the horsepower of an Edge TPU chip, you can still run Cloud IoT Edge and do local inference on your edge device which has a GPU or just has a CPU itself. So it's pretty flexible that way. And the second component is IoT Core that securely connects your edge device to Google Cloud. So you can do you can manage your software. You can do software and firmware updates. You can exchange data and also exchange machine learning models between your edge device and the cloud. So combined with these two key components, what Cloud IoT Edge offers you is a software runtime for running machine learning inference, but also to orchestrate your models and data exchange with Google Cloud. Let's take an example. Say you have a factory with a high-velocity assembly line, and you want to detect anomalies real time. And you have a camera that has our Edge TPU chip, and you have that's running Android things and has our Cloud IoT Edge software runtime running on it. And you have collected historical data from your assembly line production, which you can then use, which using cloud machine learning engine, you can train a model to accurately detect defects. You can then push down that model to the camera via our Cloud IoT Core and Cloud IoT Edge software. And using Edge TPU, now you can do real-time detection of anomaly on your high-velocity assembly. So with Cloud IoT Edge as a software and Edge TPU chip as our hardware chip, together with our cloud platform, you can really build an integrated AI solution with our Cloud IoT platform. Now, let's look at Edge TPU. And to tell you more about Edge TPU and the motivations for building Edge TPU chip, let me invite my friend Olivia Temam, who is the tech lead for Edge TPU in the Google AI team. Olivia.
Thanks, Indranil. So good morning, everyone. It's a real pleasure to be here with you today to talk about Edge TPU. And actually, what we want to do is not only to present you what Edge TPU is, but we also want to explain why we have developed Edge TPU at Google. And to do that, we want to walk you through the 4 key motivations that you see on the slide. So the first motivation that we had is we want to bring high-quality AI to the edge. And by high quality, I mean high speed and high accuracy. So at Google, we are developing machine learning models for the edge. One of our flagship models for image classification is MobileNet. And it's not a unique feature, but one of the nice things about MobileNet is that it's a highly configurable model, and you can easily trade more computations for more accuracy. So just to get an idea of the relationship between the two, let's look at this graph, where you see on the x-axis the computational cost of running one inference at the edge, expressed in millions of multiply adds, and on the y-axis you have the accuracy. So if you're shooting for a moderate amount of accuracy, like 60%, you're going to pay 60 million multiply adds. That's 120 million operations. But if you want to bump that up to 75% accuracy, you're going to have to pay 10 times that cost, 1.2 billion operations. And that particular graph stops at 600 million multiply adds. You can invest more computations to get even more accuracy. So the point here is that the computational cost of high accuracy is very steep. And what we want to do there, in order to sustain high-quality AI at the edge, is to deliver high performance, but because this is also about embedded applications, we have to do this at a very low cost and naturally in a small physical and power footprint. And that was basically the first charter that we had with Edge TPU. So the second motivation that we had relates to what Indranil just explained. We are building an end-to-end AI infrastructure, cloud to edge, AI to hardware, and the key goal is to make it as easy as possible for our customers to deploy their AI-based solutions by piggybacking basically this infrastructure. So it involves work across the 3 stacks, AI, software, and hardware naturally, and as you all know, we have already been developing a custom AI hardware solution for the Cloud TPU. So by introducing Edge TPU, the other thing we wanted to do is to complement that infrastructure. So again, to make it as easy as possible for our customers to deploy their solution. Now, we think actually Edge TPU is going to bring a lot of value to our customers in terms of helping them deploy AI at the edge. But we also are developing an open infrastructure. So we see Edge TPU as only one option that we are making available to our customers, and customers remain completely free to choose any hardware solution they want. So the third motivation that we had is more technical. And it relates actually to a fairly fundamental point about custom hardware design, which is actually very often overlooked. It's a simple one, but it's very often overlooked. And it's the fact that custom hardware design is all about leveraging in hardware the properties of the algorithms. So in this case, AI algorithms. So that can be a challenge for hardware designers because it means they have to develop a fairly intimate knowledge of the target algorithms of AI algorithms. So that can be a challenge for most organizations, but for Google it can also be an opportunity because all hardware designers have access to abundant AI expertise, and therefore they can know what are the latest trends in AI, and that can help them decide what kind of features they need to bring within their hardware designs. Now, that's one advantage of having both expertise, hardware and AI within the same company, but it's not the only one. What we can do, and what we're increasingly doing, is that we can also go the other way around and start adapting AI algorithms so that they work as well as possible on the custom AI hardware. And the last point is that probably one of the biggest misconceptions about custom AI hardware is that it's primarily a hardware task, while in fact the biggest difficulty is the software layer which you use to map AI algorithms onto the custom hardware. So what we're really striving to do is to develop a holistic approach across the three stack, and in both as a conviction but increasingly based on our experience, this is what is going to yield the best results in terms of custom AI hardware design. Our fourth motivation relates to this one, to the one I just presented. So it's not only that our hardware designers have to have access to the latest trends in AI, but it's also that AI is evolving extremely quickly. This graph that you see here has been collected by colleagues at Google AI, and it shows the number of AI-related research articles which have been submitted to arXiv over the past decades. And the key message here is that this curve is exponential, has an exponential, basically, shape. So there is, just underlines the very rapid progression of AI. So that, again, can be both a challenge and an opportunity. It is a challenge because, as you know, the timeline of hardware is very different from the timeline of AI research. But it can become an opportunity if we learn to tackle in hardware this rapid evolution of AI. If we do that, then what is going to happen is that the performance of the custom AI hardware, again expressed in speed and accuracy, is now going to progress more or less at the same pace as that of AI algorithms, and as you can see, that's very fast. So one way to think about it is that increasingly AI algorithms are playing for custom AI hardware more or less the same role as transistor technology is playing for general purpose architectures. And when we set on to design Edge TPU, from the beginning we had that objective in mind, which is how are we going to tackle this very rapid evolution of AI? And what we've designed is actually, what we've created is not just one design, but it is a design approach exactly for that purpose. That's also why when we think about the first chip that we are presenting today, even though it's achieving a very good performance per dollar ratio, which we think is going to help disseminate high quality AI at the edge, we also think about it only as a first step in a long journey, which is going to be largely driven by AI. And we are already well underway with our second design, and we've already started to work on the third design. And at every step, what we're going to do basically is to improve the AI support, improve performance and power, and bring more functionality. So those are some of the key motivations that we had actually to design Edge TPU. And now to present you in more details what we are going to provide to our customers in the coming month, I'm going to invite AJ, who is the Edge TPU product manager, to present you that. Thank you.
Thanks, Olivier. Good morning, everyone. I'm Ajay Nair, the product manager for Edge TPUs. We'll go over quickly on what we are releasing and how users can have access to what's being announced today. So that is the Edge TPU. One thing to note here is that the 1 cent that is shown is indicative of the size of the Edge TPU. It does not indicate the cost, right? Uh-oh. But in all seriousness, though, when we were designing the Edge TPUs, we were striving to achieve very high performance per dollar. And I'm proud to say that we've been able to achieve that. Our goals have been met. And we've been able to do that at a relatively low power footprint and also physical footprint on how big the Edge TPU is. And a combination of the high performance per dollar, low power, as well as the low physical footprint allows broad deployment of Edge TPUs in multiple applications. And it helps our goal to democratize AI. In terms of the Edge TPU itself, the first generation that is being announced now in the roadmap is an inference accelerator. And the architecture was optimized for vision applications. Of course, it's an accelerator. It can be used for multiple models, but it was optimized for vision. It can run concurrent state of, and what you can do with an accelerator at the edge is essentially run multiple state-of-the-art models concurrently, for example, on a high-resolution video without losing frame rate, right? As an example of what Olivier mentioned earlier, the MobileNet V2, we can achieve several hundred inferences per second on the highest accuracy versions of those models. So what we are announcing is not just the hardware, though. What we are trying to do is bring the leadership and the expertise that Google has in hardware, software, and AI, and combine those into a solution which customers can have access to. So as Indranil pointed out earlier, we already talked about the Cloud IoT Edge and the Edge TPU and how they interact. We are adding components which make use of our expertise in AI as well as software. So in AI, for example, we will be releasing at the time of the product launch, which is in October when early access customers can have access to this the product. We'll be releasing a set of pre-compiled models. These are going to be compiled to TensorFlow Lite, which is Google's open source AI framework for the edge. And TensorFlow Lite allows low latency at a small binary size for your edge applications. We'll be announcing models, for example, that are MobileNet-based models and other architectures as well. And it'll also be integrated with MLKit. MLKit is a beta product that Google announced a few months ago, which has an SDK which allows users to have commonly used AI applications at the edge. And if you have more complex needs, MLKit also provides an API for you to serve those models onto your edge devices. A next step after that is we would enable transfer learning on those pre-compiled models that we are going to be providing. So what is transfer learning? Transfer learning is a method where you can repurpose an existing model, which is made for one use case, and customize that based on your own data sets for your specific use case. So that's a very powerful method, and it really helps because the investment needed from users in terms of the time, the effort, and the expertise in machine learning is vastly reduced. So the existing pre-compiled models can be repurposed. You can bring your own data and reuse your data for your specific application needs. In a future update, we will also be releasing the TensorFlow Lite compiler for Edge TPUs, so you can customize, or you can start your model design from scratch. We also want to make it easy for customers to deploy Edge TPU at your applications. The idea being we would like you to be able to envision your use cases that serve your business needs. And using the products that we are going to be releasing, you can iterate and prototype, use the models in your hardware applications, use the transfer learning function to optimize those models for your use case and test it out in your system. And when you're satisfied with the results, you deploy that in your real applications. And we are also announcing and making available the Edge TPU development kit. And there are two versions of development kit depending on where you are in the ecosystem. If you want a fully integrated solution with the Edge TPU connected to an SoC, what we are announcing is a system-on-module. So what you see here is a system-on-module. It has the Edge TPU ASIC, connects to a CPU, and also a crypto for security. That module connects on to, I'll take a break there. The Edge TPU is that red square that we're seeing there, and this is to scale, by the way, in terms of the famous 1 cent. The Edge TPU SOM connects to a baseboard, and the baseboard essentially expands the I/O connectivity options that are available. So there's a whole slew of connectivity there. That you have USB-A ports, USB-C, HDMI. There's a MIPI interface to connect your camera onto it. It's got a Wi-Fi interface, an Ethernet, and a 5-volt DC power to power the devices. So if you need a fully integrated solution, this is what you use. The SoC will have Android Things preloaded onto it. It can connect onto the internet. You can download the precompiled models that we mentioned in the previous slides, and you can run inference locally. It also will have the IoT Edge solution. So once you run inference locally, your application can decide what to do with the local data, and also use IoT Edge to load back the data as you need back to the cloud for storage or retrieval or for further analysis. We are also announcing the Edge TPU accelerator. It's a USB-C form factor device. And if you have an existing system that has a host interface available, you can just connect the Edge TPU accelerator using the USB-C onto your systems and accelerate your machine learning workloads. So both of these solutions have been designed internally at Google with partnership from external vendors for different components. It's been designed by the Google AI team, which is a team within the Google AI business function. All right, and to show some functionality of the boards and what we can do with it, I'd like to invite Preston onto the stage. Preston is our head of IoT solutions, and he'll help us showcase what a quick example of what the Edge TPU can do. Thanks.
Great. So as Ajay said, let's take a look at some of the performance capabilities of Edge TPU. So I'm going to mostly be off stage and run you through this demo. What we do is we have two systems set up here, one with Edge TPU and one without. And so we wanted to show you some of the performance differences as well as how you combine the inference on the edge with sending data to the cloud. So give me 1 second to start up some things. And actually, if I could have you guys come over here, because you're accidentally actually in camera, not as planned. So if you can come over to with the other folks on the far other side. So what we've got is we've got two cameras set up. Yeah, your seats were in frame. So we've got two cameras set up, and what we're using are high-resolution cameras, high frame rate cameras. These are 1080p cameras filming at 60 frames per second. And you can see already that if you look at the top frame, that is a system without the TPU, the frames per second in which we're able to compute and analyze the video are already down to like 13 frames per second, whereas the frames per second with TPU are still at a very high frame rate processing of 45 frames per second. Now what I'm going to do is I'm going to invite my colleague Matt, one of the IoT engineers who helped us with this demo, on stage. And so you can see that as Matt walks on stage, we've detected Matt. We see him on stage, and you can see that already the frame rate's starting to drop a little bit without the TPU. Now, all of this inference, all the ML that's detecting Matt on stage is happening entirely on the edge. So we're not able to realistically stream this kind of high frame rate, high resolution video directly to the cloud. So we need to be able to compute on this information that's so rich strictly on the edge. But since we have now some information we're interested in, we can detect essentially some information about what we're seeing. So one of the things is we can now look at just a simple metric of how many things have we detected that we're interested in the frame. And we may average this out over 5 seconds locally on the edge so that we have a simple metric that we can then send to the cloud. And once we're sending information on the cloud, we can start to visualize it in things like a dashboard. So I have, starting out here, a very simple dashboard that I can just see that we have one person on stage right now. But as a few other colleagues gradually join Matt, and we increase that number, we can start to look at what that performance is. So in this case, we're not only going to send just the count of people, but we're interested in some more information about the performance of the actual system here. So I'm going to switch briefly to the dashboards for a moment so you can sort of see what that looks like. So here we're looking at 3 pieces of information. The top is the number of objects detected. The second graph is the frame rate. And then the third is sort of a gauge of the instantaneous frame rate. And you can see that with Edge TPU, we're still holding steady at about 30 frames per second of effective processing. Now, this is not just one model running per frame. We're actually running a complex set of cascading models. So we're doing many inferences per frame to achieve the information we're interested in. And so as you can see, that as the number of people in frame goes up, the inference really starts to drop without a TPU. And why does this matter? Well, if you're looking at something like this very sort of high frame rate, high resolution video, it lets us do a couple things. One is it's letting us detect, that there are still people who might be very small in the frame, right? So if you're thinking of looking at, say, very small defects on equipment, surface defects or small parts, high resolution allows you to still provide the machine learning full information. And we're not only using high resolution on the camera input side, we're actually not extremely downsampling that video to feed to a model. So we're able to feed high resolution directly into the model because of the computation power of the Edge TPU. And as these numbers increase, you'll continue to see sort of frame rate dropping on the left. But we want to be able to sort of also show that why does a frame rate matter? If we're losing frames, what are we losing? So this model is not only detecting things like the person on stage, but we're able to detect a degree of information about what their orientation is, what their attention is looking at. And we can count these as essentially glances at the camera. Now, these are glances that last only a moment. And so if we look now at the way we've counted glances between these two systems, you can see that many glances are simply missed by the system without a TPU because they're so momentary. And if you think about applications of the TPU in places such as high-speed manufacturing lines or other places where momentary information that might exist in an acoustic signal that will be dropped or missed, these essentially act as sort of dropping important events in the system you're trying to analyze. And so as these systems are unable to keep up, you're essentially losing critical information. And again, all that we're interested in on the cloud side here is these counts and metrics. We don't have a need to sort of send the complex or potentially sensitive information that's happening on the edge directly to the cloud for processing. We can keep that processing happening strictly on the edge. So thank you very much, colleagues. And with that, I will return the presentation back to Indranil.
Thank you, Preston. So as you can see, for the clicker. Oh, there it is. Thanks. Thanks, Preston. So as you can see, with Edge TPU, the number of inferences and the inference you can do at a high frame rate is much higher than what you can do without Edge TPU. And we've run multiple models in this demo. These models were internally built within Google just for the purpose to showcase the capabilities and the horsepower we have with Edge TPU. We don't plan to make it publicly available, but you can use in your own model you can train your own model using cloud machine learning engine, and then use our Edge TPU to where you have use case for such high processing, real-time analysis. So, since as we started working on this, we've been also engaging some of our early customers, and the feedback from these customers has been really positive. LG CNS, for example, has used our cloud machine learning engine and our Edge TPU and Cloud IoT Edge on some of their cameras to really improve their productivity by detecting defects in their fast assembly line real time, right? So they're really excited about using our integrated platform to improve productivity in their production line. Smart Parking is another of our customer who are using this Edge TPU and also looking at Cloud IoT Edge and the overall platform to really revolutionize the parking experience by pushing intelligence to the edge with the entire platform. So we're pretty excited with where we're headed with overall our Edge story, and the positive feedback from the customers is really encouraging as well. Now, we understand that for when we build a platform, and as we start offering our Edge solution, we really want to work with our partners' ecosystem. So we've started engaging with a couple of our key partners. For example, in semiconductor companies such as ARM, NXP, are working with us to build the system and module with Edge, as I showed in his slide, using the Edge TPU, which can be used by other device makers. We are also working with some of our key gateway device makers, such as Hitachi Vantara, Harting, Nokia, Nexcom, and Acton, who are evaluating our platform to take those Edge TPU SOM into their industrial gateway so they can push the intelligence to the edge and really offer it to their customers and take it to the market. We're also working with some of the edge computing companies such as AD-Link, Kelvin, Olia Analytics, SmartCatch, Trax, who are building smart solution using our Cloud IoT Edge software, Edge TPU, and the overall integrated AI platform for the Edge solution as well. So we're working hard on the partner ecosystem. We're going to continue to work with a lot of more partners, and we're very excited with the partner response we have gotten so far. So as you can see, just to sort of summarize, we are really working towards an integrated AI solution so that with our Cloud IoT platform. What you heard today is our Edge offering. So Edge TPU chip, which is our high-performing hardware chip for machine learning inference on the device itself. Cloud IoT Edge, which is our software stack for running machine learning inference on your Edge device, which you can run on Edge, which is optimized for Edge TPU and can also work when a device that doesn't have Edge TPU. And this works seamlessly with our Cloud IoT platform, which includes Cloud IoT Core as a managed service, PubSub, Cloud Machine Learning Engine, and other services as well. So we are very excited with our integrated AI solution with Cloud IoT platform, and we can't wait. We can't wait to see where enterprise developers and customers can build with this platform. So next steps. We're offering early access this is an early access program with Cloud IoT Edge and Edge TPU. You can sign up for access on these sites. You can either go to cloud.google.com/IoT-Edge or cloud.google.com/Edge-TPU. And our plan is that we will initially provide access to select customers, get their feedback, and then by fall, we'll start offering the Edge TPU board to more broadly and to collect more feedback so we can refine our platform and really make it such that it's seamless and it's integrated for enterprise developers and customers to build integrated AI solution. So with that, I really want to thank you all for coming over here. We we will be waiting here for a couple of more minutes. So if you guys have questions, you can come on the side of the stage and ask us questions. But really excited with where we're heading, and thank you for your time.